Hello, ma'am. My name is Tanvir Muhammad Hassan, and I am going to talk about one of the core concepts of object-oriented programming, abstraction. This concept is widely used in software design to manage complexity and focus on the essential parts of an object. So, what exactly is abstraction? In simple terms, abstraction is the process of hiding unnecessary details and showing only the relevant features of an object. It's like using a device or machine without needing to know how it works internally. In OOP, abstraction helps programmers focus on what an object does rather than how it does it. This helps reduce complexity and makes the system easier to use and maintain. Let's take a real life example, driving a car. When we drive a car, we use the steering wheel, accelerator, and brakes, but we don't really think about how the fuel gets converted into the energy or how the engine piston move. All of that is abstracted away from us. The same concept applies in programming. You use a function or a method, but you don't always need to know how it's implemented behind the scenes. Now, you may ask, why is abstraction important? There are several reasons. First, it reduces complexity. You don't need to overload your brain with unnecessary details. Second, it promotes code reusability. Once a method is abstracted, others can use it without rewriting code. Third, it enhances maintainability because you can change the internal implementation without affecting users. Lastly, it improves security by hiding internal logic from the outside world. In programming language like Java, C++, or C hash, abstraction is mainly achieved in two ways using abstract classes using interfaces. Both of those allows us to define methods that must be implemented by other classes without actually writing the implementation ourselves. Here an example of an abstract class in Java. We have an abstract class animal with an abstract method make sound and a concrete method eat. You can see that abstract classes can have both abstract methods which don't have a body and concrete methods which do. An important point is that abstract classes cannot be instantiated directly. You must create a subclass to implement the abstract methods. Now, let's talk about interfaces. Interfaces are similar to abstract classes but with some key differences. In this example, we have a vehicle interface with two method declarations start and stop. In older version of Java, all methods in interfaces were implicitly abstract, but in modern Java from Java 8 and onward, interfaces can also have default and static methods. A major advantage of interfaces is that a class can implement multiple interfaces supporting multiple inheritance. Abstract class versus interfaces. So, how do abstract classes and interfaces compare? Abstract classes can have both abstract and non abstract methods, while interfaces mostly have only abstract methods. Multiple inheritance is not supported with abstract classes, but in interfaces it's supported. Abstract class can have constructors, while interfaces cannot. Also, abstract classes can define access modifiers, for methods, but interfaces, especially in earlier version of Java, cannot. Here an example of how to use the abstract class. We have a class dog that extends animal. Since animal has an abstract method make sound, the dog is required to provide an implementation for that method. This is a great way to enforce that certain classes must follow a specific behavior. Now let's look at the interface example. We have a class car that implements the vehicle interface. It provides its own implementation of start and stop methods. This allows us to define contract to the inherit interface, and each class can implement it in its own way, whether it's a car, bike, or even a drone. So, when should we use abstract classes and when we should use interfaces? Use abstract classes when you want to provide a base class with default functionality. On the other hand, use interfaces when you want to enforce a structure without worrying about implementation, especially when your class needs to inherit from multiple sources. Knowing when to use which makes your design more flexible and future proof. To wrap it up, abstraction is all about hiding complexity and exposing only the essential parts. It helps make code cleaner, easier to manage, and more secure. It's one of the most powerful tools in OOP and it's everywhere, from small programs to huge software systems. Thank, thank you for listening. Thanks.